MEMS technology and SPI protocol. What is MEMS technology? MEMS or MEMS is the acronym for Miniaturized Electromechanical Systems. It is a type of fabrication technology used to manufacture microscale sensors such as the accelerometer, gyroscopes, and pressure sensors. MEMS is a precision device technology that integrates mechanical elements, sensors, actuators, and electronics on a common silicon substrate through microfabrication technology. MEMS reduces the external circuitry for getting output signals. Let us find out how this technology is used to manufacture sensors such as accelerometers, which we use quite often in our prototyping. One can go ahead and see the extent of reduction of size while using MEMS in the picture presented in front of you. It is very appreciable, at the same time very efficient technology. MEMS in accelerometers. How is MEMS used in sensors like accelerometers? As we know, accelerometers measure the acceleration, but the question you must ask now is whose acceleration must be taken as a reference? We live in a world of relative frames, which means that we need to measure any quantity which is relative to a standard quantity. This is the normal protocol and the standard rule. To put it simply, in this physical world, we need a reference standard value to measure any quantity. For an instance, if you say the room is hot, then you are inferring with a reference to 0 degrees centigrade as the standard temperature. So, when we measure the acceleration of a body with this sensor, it means that we measure it with respective to a mass acceleration that is present inside the accelerometer sensor. Now, let us take an in-depth look on the working of a MEMS accelerometer. It is very important, and most importantly, we need to learn it extensively. It contains a fixed mass whose ends are tightened to a stationary frame. I repeat, it contains a fixed mass whose ends are tightened to a stationary frame. According to the Newton's law of motion, acceleration is generated when an external force is applied onto the middle of a mass. And we know the formula F is equal to m cross A, where F is nothing but the force applied by the external activity, m is nothing but the mass present in the sensor, A is nothing but the acceleration generated as a result of the force. The acceleration is used as the reference value. But how is the output voltage signal generated just by a movement? We need to understand that clearly. Now, we make use of the concept of capacitance to convert the physical motion to an electrical quantity. Remember, capacitance concept is all the fundamental concept that we are using here. The distance between the fixed electrode and the movable mass acts as the differential capacitor pair as shown in the figure in front of you. I repeat, the distance between the fixed electrode frame and the movable mass acts as the differential capacitor pair as shown in the figure that you can see in front of you. The differential capacitor pair is being highlighted right now, and remember, this is the fundamental point that you should understand clearly. When the mass moves the distance d1, there the d2 changes. When the mass moves the distances d1, there the d2 will obviously change. Hence, the capacitance varies. And this results in the change of the output voltage. This voltage change is amplified further and sent as a sensor output signal. The same setup can be designed to measure the accelerations in all the three axes, and that is how the fundamental accelerometer works. It is time for us to understand SPI. What is SPI? SPI is Serial Peripheral Interface. It is commonly used protocol in the interface peripherals such as the LCDs and sensors. SPI protocol is more complex protocol when you compare it with I2C. Unlike I2C, this protocol uses 4 wires to transmit data from master to slave and vice versa. Every protocol anticipates the address of the sensors to begin the communication. It is similar to a postman who requests the address for delivering the letters to an appropriate house. Here, the address of the house is the binary address of the sensor, and the letter to be delivered is the data to be transmitted. Let's quickly understand the differences between SPI and I2C. SPI is a 3-wire protocol, whereas I2C is a 2-wire protocol. SPI is full duplex serial bus based, whereas I2C is implementable for multiple sensors. SPI is little expensive, I2C is inexpensive. SPI has got one master support only, I2C has got multi-masters and slave support enabled. Let's get into much more details of SPI. SPI is full duplex master-slave serial bus. It can accept only one master device to be connected over a SPI bus, but multiple slaves can be connected. There can be only one master, but can have multiple slaves is the point to be reiterated. The lines present in the SPI bus are MOSI, MISO, and SS. MOSI is nothing but the master out slave in. You can see the pin out here in the diagram. MOSI and MISO is nothing but master in slave out, and SS is nothing but the slave select line. It is called as the slave select line. These are the three lines used in the SPI communication protocol. The MOSI pin is used to send data from the master and the slave receives the data. The name specifies it clearly: master out, slave in. MISO is used to send data from the slave to the master. It also specifies very clearly through the name: master in, slave out. And finally, the select slave plays an important role in determining the sensors to communicate. If the master has got multiple SS lines, then we can connect multiple peripherals to the SPI bus. Once all the select pins are occupied, no more peripherals can be connected, and that's the restriction. Let's now understand the addressing scheme for SPI. The figure in front of you is graphical, and that is sufficient for anybody to understand the addressing schema. The addressing schema presented shows how the data is sent to access the address registers of the sensor or the peripheral device, and how the data is sent over individual clock cycle. As discussed, the address is acquired and then the master sends the data to the slave using MOSI, and the data from the sensor is received using MISO. I repeat, MOSI and MISO are the two very important lines that we need to understand. If the clock signals, clock cycles are high, then a microcontroller can run a number of instructions so that the high clock speed MCUs can transmit more data. It's time to understand SPI versus other protocols. Similar to I2C, SPI can be implemented in sensors such as the accelerometers, NFC modules, RFID modules, and micro SD cards for Arduino. It must be remembered that one cannot quickly arrive at a conclusion that a particular protocol is always meant for a specific application. A unique protocol has not been designed for all applications because the data transmission need not be the same for all those. For an example, CAN bus is designed for automobiles, UART is designed for serial communication, and many other protocols are designed as per the real requirements. Let us find SPI in Arduino. SPI is supported in Arduino, and it's time for us to understand where exactly these SPI pins are specified and located in the Arduino. The pins D11 and D12 are the most important pins when it comes to Arduino Uno and Nano, where D11 in both represent MOSI and D12 represent MISO. Similarly, D10 and 13 are designated as SS and SEK respectively, and the same has been presented to you in the picture by highlighting the blocks. Thank you.